All right, in this video, I want to introduce a new object-oriented concept called inheritance. This is really key. I think what you really often find when you have different types of data is that some types of data are more kind of similar to each other than others. So for example, maybe 5 is an integer and 3.14 is a float. So those are two different types. I have int and float. But more broadly, I might say that they're both numeric types, and that means I can do a lot of the same things to both floats and ints. I can add them, divide, whatever. And so as we're building new types, we're also going to want to think about what kind of hierarchy do we have? What is kind of specific to this new type, and what do some types have in common? That's maybe kind of a more general type. And so maybe one picture that we could have is kind of a hierarchy like this, where we have all these different types, and then kind of at the bottom from these different types, we might make actual objects, right? So this hierarchy of types, you can kind of think of those as classes, and then we create objects from classes, right? So you can see that, from a class, I might kind of have another more specific kind of class underneath that, or I might take a class and use it to make objects. And well, let's just take people, for example. Maybe I have a person class, and maybe all persons have some things in common. Maybe everybody has a name and an age. Maybe most people have a social security number. You can imagine there's a lot of things we might want to have for all people. But of course, there's different kinds of persons in the world. Like you could imagine, maybe even just with respect to the university, we might have people related to a course. And within the course, we might have students, instructors, TAs. And they all might have some kind of information in common, but there's going to be specific things like maybe for instructor and TA, there's some information about what they're paid. Maybe for students, there's some information about, well, what their grade is, and so on and so forth. Right? Maybe there's other kinds of employee, right? Maybe there's administrators and janitors. And so we can see that even though we have person very generally, we have kind of subtypes of person and then subtypes. And just a little vocabulary there. Person is an example of what we might call a parent class or a base class. And then when we have a more specific type, we'll call that a child class. Now, one thing I want you to think about is that can a person ever be more than one kind of thing? And the answer is absolutely they can. An instructor is a course person, right? I have information about the course as a course person. And I'm also an employee. Thankfully, I get paid. Right, so you might imagine hierarchies that show up in the real world where it's kind of you have two parent classes the same. Now, not every programming language in the world allows this, but it's allowed in Python, right? So we're going to learn at least a little bit about that this semester. It's called multiple inheritance. We might say a child class inherits from a parent or base class. We're going to see cases where you inherit from multiple base classes. Now, the one last thing I want you to notice here is that at the very top, I have a class with a very confusing name, and the name of that class is object. Object is the most general class, and every class we ever make will somehow inherit from that, whether or not we're kind of explicitly trying to do that. I don't like that name because at the bottom I have these blue boxes which are actual objects, and the thing at the top isn't an object, it's a class. Okay, so I'm going to head over and actually do some coding examples to make this more concrete and try to demonstrate some of these principles. So I'm going to head over here, and I have my good old dog class again that we're all getting so familiar with. I have a constructor, the dog can speak. I have some stir methods, and so a repr method. So when I kind of put this down here, I'm calling stir automatically. When I put this here, I'm calling repr automatically. And let's say that I want to create a cat class. And so I'm going to do that. I'm going to create my cat class. And cats have a lot in common with dogs. Maybe they're quieter, so maybe I don't want to speak. But you could easily imagine that I might put all of these things up here, just like before. And maybe I would try to change it. Maybe this is a cat, and this is a cat. And let's just for the sake of example, let's see if it works, right? So I'm going to say Kevin equals a cat named Kevin, and well, let me just print both my animals, and that works just fine, right? But I copied and pasted, and one of the things that we stressed a lot in the last course is that whenever you're copying and pasting, it probably means you aren't doing things the most elegant way. I mean, it's more work. And then, of course, you can imagine, well, if I have a bug in my dog class and I fix it, does that mean I have yet another bug I have to go fix in my cat class? In general, we want to avoid copy and pasting. Okay? And so how do we do that? I mean, I don't want to have just one class called animal because there's some differences, right? I mean, the dog speaks differently than the cat, but there are also some things in common, right? Like these stir and repr methods are pretty similar. And so what we'll do, right, even though I really only want two classes here, I'm going to make a third class, which is kind of a more general category. And I'll call that animal. And, well, I should actually be specific here because, like, these cats and dogs, they both have names, and that's kind of what I'm having in common. So maybe I'll call it pet. So I'm going to have a pet class. And pets are just going to, well, maybe I'm not even going to call it pet. I'm going to make it a little bit more general, named animal. And named animals, I can do things like this. I can convert them to a string or a repr. And what I'm going to do is, instead of having two copies of these methods, is I'm just trying to put it in one place. Right, so I'm going to put all of this up here, like so. And I guess I shouldn't call it cat anymore. I was trying more general. I'm just trying to say animal and animal. And what I would like is for these methods, these things that are common to all named animals, to get pulled into both my cat and my dog class. And the way I pull these methods in is I say, well, in parentheses after the class name, I say named animal. So named animal up here. Okay, so that'll pull all these things into my cat class. And the same thing down here, right? I may have named animal. I may get a copy of these methods down in my dog class, right? So I run this, and I see, great, it's working for both of them. I have animal Fido and animal Kevin. Now, I guess I kind of lost a feature there, right? I mean, I'd still like to know that Fido is a dog and Kevin is a cat. And so I can go up here and I can deal with this. And the way I'll deal with that is I'll kind of think about what type of object I'm dealing with, right? So when I do this print, it calls stir on Fido, and Fido is a dog object, right? So when I get the type of self, that's like saying the type of Fido, and guess what? That's a dog. And then the same thing down here. When I call print Kevin, it calls stir on Kevin, right? So self refers to this cat here, right? So then I can see if I get the type of that, I get cat. And so one of the things I can do is when I have a class like this, I can pull out a name, right? So this type here, that's giving me a class, not an object. And I can say dot underscore underscore name, and I can do dog or cat. Now notice that we have all these special methods, right? That are the underscores, and this is not a method. If this were a method, I would do that. So it's not a special method. This is a special attribute, right? So remember that classes have both methods and attributes. Just like we have special methods, we have special attributes, and they kind of have the same weird naming with the double underscore. Okay, so I think what I can do now, since I'm able to get dog or cat and figure out what it is, instead of saying animal here, I can just put this, just like so, and so I can run that, and you know what I'm doing? I'm kind of mixing up my styles. I have to put that over here. Okay. Well, what does this do? Remember the format method? That kind of plugs values into where I have parentheses, right? So I was kind of plugging this in here, and so I get dog, and I'm plugging this in here, and so I get Fido. How was I mixing formats? Well, instead of saying dot format, the alternative to this is I can put these pieces directly inside of here, like this. I can do this. This is kind of the same thing, these two ways I'm doing it. And if I don't want to call that format method, then I have to say at the beginning that this is a format string. This is kind of a more advanced Python feature. And so these two things are just doing exactly the same thing. I'm going to delete this, and that works great. And so I'm going to do the same format string for repr. Okay, great. So I'm able to get these two methods. They're being basically pulled into both cat and dog. And that's all fine and well. Now, there's a bit of a mystery here, and it's like, well, this works, but how come it works if I do, well, let's say I just have nothing here. I mean, I get something different, right? But it doesn't crash, right? How is it that I'm calling the stir method and I'm getting something, even though right now all my stir and repr methods are commented out? Okay, that's a mystery. And let me kind of show you what's happening here. So if I have a class, like let's say dog, it turns out just like objects can have special attributes, classes can have special attributes too. And an important one to remember for classes is the method, resolution, order. Method, resolution, order. Great. And what that will give me is it's a tuple, and it's giving me a tuple of types. And what this means is that, let's say I have a dog object, right? Like for Kevin, right? Or I guess Fido. Fido is a dog object. If I call Fido.speak, it will first check, does my dog class have a speak? Well, and it does. If it didn't, then it would check, does named animal have a speak? That's kind of like the second choice, and that's why it's the second place in the tuple. Well, and if that doesn't have a speak, it'll check if the object class, remember that object is the weird name for the class that's kind of the parent of everything? It'll check if object has a speak method. And object doesn't have a speak method, but it does have a stir method. And that's why even though I don't have any stirs up here, well, object.stir is what's printing this thing out, and what's printing this thing out. And so, well, what happens here? Well, when I do this, when I kind of bring this back, kind of strangely, there we go. When I bring that back, it turns out that dog doesn't have stir, but named animal and object both do, and it's choosing the one in named animal. Right? And so, well, what that means is that I have this opportunity. Well, what am I saying? So I have the method here. When this one, which has higher priority, has that same method, I say that named animal is overriding the stir method. And I can do that same thing here. So for example, let's say for dog, right? I'm just going to do this. I'm going to say stir self. And I'm just going to return like something silly for now. So even though dog is pulling in stir from named animal, that's not going to be the one that gets called when I print my dog. It's going to be this one, right? Because in the method resolution order, dog is taking precedence over this. So I do that, then I get test, right? But so just kind of an example, I don't actually want to do that in this case. I'm going to get rid of this. This method resolution order is really useful to understand new classes that you're kind of exploring and learning about. Okay, so we talked about inheriting methods, right? So when I do this, I inherit method. We talked about overriding methods and how the method resolution order can kind of help us see when that's happening. The other thing I want to talk about is for our init method, how could we call init or other methods in a parent? Right? Maybe we want to both override it and still call the parent one. Right now, I haven't really given you a choice. Like either we override it or not. How can we have a choice to do both? So let's think about how I'm going to do this here. Let's say that, well, let's do this first. I'm going to say that I want to put this up here. And how did I get this all kind of indented in? It's a little funny. Let me put that up here. So I don't need any constructor here. And I'm just going to comment this one out for now. Everything still works the same way because the net, just like anything else, is getting pulled into these two classes. But what happens if, as I have my dog, I want to have more information for my dog? Let's say I want to have like an age for my dog too. So I can say like age equals age. And then I guess Fido is 5. And why is my line 19 just kind of off? Let me just kind of tab this in. That's very, let me just like do a kernel restart and run all. I feel like the colors are wrong. Why is that red? Oh, well, kind of mysterious. Anyway, I guess I'll just leave that as it is because, oh, it's really bugging me. Sorry. There, does that work? Great. Okay, I'm just going to leave it like that. Um, where was I? Sorry. Okay, so I've overridden this. Now, you can see I have some redundancy again, right? I kind of copied this down here. And that's kind of okay because there's just one line of code. But what if there was, imagine there's kind of lots of setup here, right? It would be kind of silly to copy all of this down here, wouldn't it? And so what I'll often want to do is override a method, but then still call the parent method. And so the way I'll do that is like this. I guess there's a couple ways. So how can I run this instead of redoing that work down here? One way is that I can be very explicit about which one I want to call. I can say named animal dot init. Remember, this is kind of like the old style we saw for calling methods. It doesn't have the type-based dispatch. And I could pass in these three things, right? I could do this. This is one option. And why is that broken? Because up here, I guess I need the two things, right? Named animals don't know about age. So I can do that. So I could do that, and that works just fine, right? So now I have the advantage of that. I can call this to do whatever stuff is up here, plus adding my own little feature down here. In Python, they kind of have this strange kind of pattern for accomplishing this. It's a little bit hard to see what's going on. I'm just going to kind of show you what it is. If I call super, that basically gives me the same thing as self, but it gives me the named animal version of self. And so if I call this, then I can say init and then just name. And for this style, right, since I'm not actually putting a class name here, I'm just kind of putting a different version of self, I don't have to pass self in here. So this would do the same thing. Does the same as above in most cases. There's kind of some more, this gets trickier in certain cases, but at least for here, that's trying to do the same thing, and that's kind of maybe the level I want to go into it for this course. And so great, I can see that now I have this capability. I can call my parent version and my own using super. So you're going to see super a lot. Okay, this is good. There's one more thing I want to talk about, which is that there are sometimes classes. Well, I guess for this class, right, I never actually create objects directly from named animals. Its only purpose is to be a base class for other classes. And there's other classes like that come with Python. They're called abstract base classes. Abstract is kind of this fancy word to say that, you know, I don't really mean to create instances of this. It's just kind of to be a base for other things. And so if I head over here, there's actually, so abstract base class, that acronym for that is ABC. And there are all these examples of abstract base classes that basically come with Python. Okay? And they're going to kind of save you time if you're trying to implement different kinds of structures. So for example, let's say that I want to make a new kind of sequence. What I can do is if I implement get item in length, then I inherit from the abstract base class called sequence. I'm going to automatically get all of these other good things. Okay? And so in this example, I already kind of have implemented a sequence, and we're going to look at the code now, and it already has these two things, but it doesn't have these things yet. We're going to come back here, and this is an example from an earlier lecture where we'd have a range, right? I could get this range of numbers, and I can get the length of the range and kind of get items from the range. And so let me just kind of create a range down here. So I'm going to do this, and I can say range equals, I'll say I'll go from like 100 to 200. I could get the value at position. Let me actually just do like, I'll do like 50 to 60. Right, so the value at position 0 is 50, the value at the next position 51, so on and so forth. So that's fine. because I implemented get item. I can get the length of it because I implemented that. What I can't do is I can't say r.index of 52. What I would like this to do is give me the kind of the index or the position of 52 within that range, which I guess is just position 2. Right, so if I do that, that crashes, right? But I can get this index method for free if I inherit from sequence, right? Because that gives me index and count and all these other goodies, right? All I have to do is have these two. So let me try that. So I'm going to say, here, I'm going to say from collections, import abstract base class. Right, so that's a module, and within that module, I can inherit from the sequence. So just by adding this little bit of code, this is going to work, right? 52 is at position 2 within here. Maybe actually, let me kind of start at a kind of a more interesting range. I'll draw from 3 till 9. And in the position of, I guess, 6, well, I guess what is 3? So 3 is 0. So 6 should be 3. Or I'll do 7, which should be 4. Great, so the index method just works for me automatically, right? And let me just try to print R to really make this explicit. And convert it to a list. Right, it's telling me that it's 0, 1, 2, 3, 4, right? The index method is there just because I added this. I inherited those methods. And so when you're trying to build new collections, and maybe collections is a word for kind of data structure, like, new kinds of lists or dictionaries or other fancy things, check out these abstract base classes and consider inheriting from one or more of those.